My name is Alan Melly, and I'm with the Pennsylvania Department of Transportation. I am a project development engineer and the digital delivery lead for PennDOT. Today, I'd like to speak about PennDOT's Digital Delivery Directive 2025. So, in today's presentation, I would like to touch on what is digital delivery, go over that directive overview, touch on the pilot projects. So, what have we done since we presented last year? And really, what are the next steps as we look ahead? So, PennDOT's vision for digital delivery is by 2025, construction projects will be bid using 3D technology and no longer be in a traditional construction plan format. This will include the also plan, such as your traffic control plan, your E&S plan, etc. But we do realize there are some plans that don't necessarily lend themselves to being done in 3D. So, with that being said, digital delivery is really that transfer of digital information. So, all of our projects will be transferring digital information from design to construction to asset management. It's that complete life cycle of a project that we're looking at completing with this digital delivery directive. So the digital delivery directive started out with our strategic plan. So in 2020, we developed that strategic plan. We utilized a team environment, went out across the state, broke the state into multiple different segments to capture regional aspects of what's being done. So we gathered that feedback from internal subject matter experts, our consultant subject matter experts, uh, contractors in each of the regions, our sister agencies. Uh, let's see, the Pennsylvania Turnpike, federal highways. So again, we tried to do this in a team environment because it's great if this initiative works for the department, but it needs to work for everybody else as well. So we want to gather all of that information of what they're doing and how they're doing it to sort of digitize what we are doing and what we are moving forward with. So out of that strategic plan development, we developed this roadmap. So this roadmap really lays out how we plan to accomplish this initiative. So really some of those keys to success to get this to that finish line is really managing that pace of change. We can't go too fast, but we can't go too slow. I mean, we have an aggressive timeline, but we have to show that we're making progress, but we can't go too fast and overwhelm either our contractors or our designers, our engineers, any of the sister agencies that we deal with. So that is a key to success. In empowering those project teams because a lot of this is going to be piloted. It has been done somewhat across the country, so we are coordinating and collaborating with a few other DOTs that have ventured in this realm. We are being watched very closely nationwide with our initiative on how we are accomplishing this. So with this roadmap, we laid out, 2021, we're looking at, what are those quick kills, those quick starts that we can really, build some momentum as we move forward. Looking at the model review checklist and, our project execution template, we, jumped in with Everyday Count 6, the Federal Highways Initiative, for digital as-built. So we actually have a pilot going on, which I'll get into here in a little bit, for the digital as-built here in 2021. There's a lot of stuff going on behind the scenes to develop to get ready for that next step, where in 2022 we're looking at, the roadway modeling requirements, where, we're modeling that roadway instead of, producing those 2D plan sheets a lot of times. So looking at those, modeling standards and, educating our, designers both internally and externally of what those requirements are going to be. and piloting various projects, which we'll get into here momentarily as well. But as you can see, we are building complexity year after year. So 2023, we're looking at the bridge and construction modeling requirements. And in 2024, we get into the drainage, the advanced asset management, looking at pulling those quantities directly out of the CAD model. And then really getting to that, 2025, where we're be able to produce that model as the legal document and no longer provide a plan sheet for some of these projects. So it will be completely digital as we deliver this. So in 2025, we will have that ability to basically give a digital file and that be the document of truth that the contractor will build from. So we broke this initiative into basically 3 phases. Our phase 1 is really that planning where we developed that strategic plan and reached out to, all of those folks to develop that plan. So phase 2, which is what we're in now, is a bulk of this initiative. This is where we are developing and looking at these various pilot projects. We're trying to take this agile approach where we crawl, walk, run, and build on complexity. So we're not, taking too much of that bite out of the apple. So it's small bites as we go and building upon that in complexity. So phase 2 is where a bulk of that is. So we're not going to flip that switch and say all of a sudden here everything's digital. We're looking at various small pieces to build upon. And then phase 3, which is where we're really deploying that, that deliverable for 2025, and we're updating the department's policies and procedures and standards and publications to match exactly what we are going to be producing for a model deliverable. So to get into some of the pilot projects that we have started, and this one here is actually nearing pretty much completion for the most part this year, we sort of worked a little bit backwards. With the digital as-built, it was a deliverable from the contractor. It was not a model deliverable. No models were provided or required back. It was actually a simple spreadsheet with various information located on it that either somebody in design, construction, or asset management would require. So with that information and that knowledge, we now have that ability to know exactly what it is that we're able to put into our system, our CAD system, to develop. This is the information we need these assets to provide us. So it will be set up and developed to accommodate all of this information as we move forward. We have 6 projects total statewide that are piloting the digital as-built. 4 of the 6 will be completed this construction season, which is nearing an end. So we'll have more information and lessons learned as we finish these projects. So we follow this all the way through from the design portion of it, the letting portion of it, and then construction and post-construction. So we will have lessons learned and so forth as we finalize this pilot. The next pilot project that we're getting into and working on right now in design, which will be let in 2022, is the single project PDF. This here again is not requiring any modeling to provide to the contractor. It's really that step to eliminate plan sheets. So these plan sheets are now going to be a single project, a single PDF. That way, instead of having, 20 or 30 plan sheets that you need to flip through, you have one. So it really forces the inspection and contracting community to look at these files from an electronic device, and will have the ability to look at the entire alignment without the need for flipping through plan sheets. We also have these set up that they will be able to turn on and off various layers. So that way, if you just want to see where the drainage is, some of these plans get very busy, as you well know. So you'll be able to turn on and off various information in these PDF files to provide you that information. So we have 3 of these projects going to be in construction in 2022. So those will be our pilots during the 2022 construction season. The next group of pilots that we are getting into is the existing ground confidence level, also referred to as EGCL, and roadway authoring. This is where we are updating our survey requirements, looking at what those requirements are to produce a model quality level survey that we're going to need to build upon. So you'll hear the term data fusion. Data fusion is where we're taking various types of survey and combining it into one to, again, produce that model quality survey. So some of your soft surfaces, you may only need 25-foot spacing, but some of your hard surfaces, your roadway, right along the roadway, you may need that point density at 2 feet. There's a lot of interpolation that goes on between, a 25-foot spacing compared to a 2-foot spacing. This is where it builds confidence for the contractor to be able to trust what we are providing to them. So we have 3 projects statewide that we are going to provide these model documents to the contractor to build from. So it will basically eliminate the cross sections or the need of cross sections. The contractor will be able to pull cross sections on these at any point. There is various software packages that the contractor and inspection forces will be able to utilize. Working with them, we will be able to provide support and recommendations as far as how to use it and walk these projects through as we are advancing these pilot projects. These 3 pilot projects will be in construction in the 2023 construction season. The next pilot that we are looking at is the bridge authoring pilot. Now, this one here, we also have 3 pilot projects going on statewide. They will also be in construction in 2023. So 2023 will be a very busy construction season for digital delivery, as we have 3 roadway authoring projects and 3 bridge authoring projects going on at the same time. This is where we are providing the bridge as a complete digital file. So those documents will be provided to the contractor. Again, they will have to utilize software packages to view and be able to understand what it is provided to them. All of the information that is provided on a typical plan sheet for the bridge projects will still be included in these models. It's just where that is located. Is it going to be on a PDF attachment? Is it going to be directly in the model? So we will train or explain exactly where all of this is for all of the contractors that are bidding on these projects. So again, these are pilot projects. We want to, work with our contracting community, our consulting community, who are going to be working on these projects. Walk these through, find out what's working, what's not working, to develop that ultimate end product, in 2025 when we fully implement this. So there will be 3 projects for 2023 for bridge authoring. So our next steps, what are we looking at? What are we doing? Really working with our, inspection forces and contracting community. We have multiple different pilots coming out here in the very near future. So again, getting them up to speed with what's going on, how to look at these, how to interact with these models, what they're getting, what information they're getting, and providing exactly what information they are requiring. So for 2024, we're looking at probably up to 8 different projects, looking at those various aspects, so drainage and utilities, pulling the quantities out of the, out of the models. So that will all be happening in 2024, looking at identifying those 2025 projects, which is a complete digital model, providing no plan sheets whatsoever. We do have a digital delivery website, which you can access here by the QR code or the link below. That has all of our information, glossary of terms, other presentations that we have provided, our strategic plan, follow along with any of the pilot projects that we have going on. We will have additional information updated constantly for that website. So with that, my contact information is here. So if you have any questions, please feel free to reach out. I am happy to discuss digital delivery at any time. And with that, I will open it up to any questions.
Welcome everyone, and thank you for attending today. I'm going to be speaking about unmanned aerial systems and their use for construction progression analysis. In this particular case, we used the Reconstruct software system. My name is John Myler. I'm an Assistant Construction Manager in District 11, and I hope you find this presentation interesting and perhaps maybe useful for you in your own projects down the road. So, you may be asking, what is Reconstruct? Well, it's a web-based software system accessible via any web browser. And what they do is they'll incorporate various aspects of your project into the system to present you some pretty cool features. So one of the things they'll do, 3D models, plan sets, incorporate those into the drawings, your construction schedule as well, drone flights for project record taking, and I'll talk a little bit more about where those drone flights come into play. And then they are also particularly instituted into vertical construction at this point, but they're looking to get into maybe some more of our construction. So they also have a 360-degree camera that you can go around and take photos of a site with as well. So once you have all that information inputted, it can make a viewable 3D model in real-time space. So they can also overlay this with, say, Google Maps, and your project will be located, and that model will appear in your 3D world, for instance. But also it's able to help us through construction with our progress. So you'll have a construction history, a timeline of details for your project. Again, you can integrate pieces of that 3D model. So if you're going to build piers, you could see where those piers are supposed to go in that real world photograph. You also get schedule indicators. So for instance, that photo on the left, you can see those members are all in green. That means they're ahead of schedule or on schedule. If they happen to be red, that would be an indicator that they're behind schedule. So some really kind of neat features there. And that's built with that model and that schedule to present this to you. And then you also get some measuring tools. So those are neat, and I think will certainly get better over time. And then also some tools to mark up the photos as well. As I previously mentioned, we're currently using the software on 2 projects here in District 11. The Kenmore Bridge Replacement Project and the McLaughlin Run Roundabout. At this time, we're only capturing drone flight data. We don't have a 3D model for either one of these projects. Obviously, we are headed in that direction in the very near future, so I can definitely see the potential of how that's going to play into this software in the future, and the benefits that we'll gain from that as well. And then I'm also going to work here, and I'll talk about that in a minute, how we're going to at least get the scheduling incorporated into the McLaughlin Run Roundabout. The other item to think about here is our potential return on investment for these services. We can reduce the need for site reviews, being able to look at the progress of the project from a remote location. You get improved project completion by really seeing how the project is progressing in real time with indicators that maybe aren't there in a CPM schedule for folks to really kind of see. You also get a good construction timeline. You can snap through those various flights and see how the project has progressed over time. You get some quick calculations for difficult measurements like volumes, and that technology is only going to get better with Lidar scans and things like that over time with the drone flights. And then obviously you'll get some really good as-built records because you can go back and review how the project was put together over its timeline. Okay, so here we're in Microsoft Edge. There's the website, reconstructinc.com. And anyone can go here now, and they got some nice videos and demos of their software here on their homepage. You can see what it can do with models. They also have the 360-degree camera there. They show that, and integration with schedules. And then just lastly, they have their return on investment details and some success stories. So with that, we'll go ahead and log in. Hit the login button. We get username and password and log in. It'll take you to your project portal screen. So we got Kenwar on the left and the roundabout on the right. We'll start with Kenwar here. And it'll take a second to load. It's a lot of data on the right there. You'll see the indicators of how that data is loading into the system. And really what it's using is the photo rendering and point cloud system kind of overlaid on the Google map. So here's the Google map on the left showing all the drone flight details. Across the top here, you have some toolbars that you can use, and I'll hit on some of those items. And kind of with that, let's zoom in. So here you can see kind of a photorealistic 3D model. Pretty cool stuff. The project was almost complete at this point. We're nearing completion now. There's also this mesh form, so it can kind of take the photos and overlay them on surfaces to kind of make it a little more photorealistic. So it's nice information there as well. These pyramids are actually high-res photos taken by the drone. So in these photos, you can zoom in on them. So here you can see very high resolution, great quality photos taken from the drone flights. That's what it uses for some of that mesh overlay to kind of make it photorealistic. So again, different angles, things like that, it can turn out pretty nice. Also across the bottom here, you'll see all the different yellow dots. Those are the different drone flights over time for the project. I'm going to go back here in June. That should work. So in June, we were just wrapping up completion of the bridge. Get ready to open it to traffic. Let's see here, mesh don't look good. Let's do point cloud. Okay, let's pan around here. So there was a temporary bridge, an acro bridge we used next to the new bridge. That's now gone. Let me go back to, let's see, February. That should work. So here in February, you'll be able to see the acro bridge next to what's going to be the new bridge eventually. We had to maintain traffic throughout construction. So again, really kind of cool photos here. Again, you can see material on site, equipment on site, good information to have throughout the life of the project. Try the mesh here. Yeah, I don't think the mesh likes the temporary bridge. But something else here. Let me fly over the bridge, show you some details on that as well. Let's try this photo. Nah. Try it again. No, let me try another one. There we go. Okay. So here over top of the bridge, I mean, again, you can see the detail. Those are the straps for the tension zone of the bridge. You can really kind of see that. Don't be scared about the rusty top flanges there. It's Core 10 steel, so we didn't miss something there on the project. And then the acro bridge next to it as well. It's really kind of some cool stuff there. With that, scroll down here to the side. I'll show you some of the markup tools that we have. Here we go. So you get a little toolbar here with various colors and shapes and freehand items you can draw on the model and photographs. You also get a text block here, so you can put text in if you need to. So that's some cool stuff there. And then also, let's see, here it is. So also you can just zap right to the image and it'll overlay that stuff in the image for the area that you're at. It'll find the closest one. So again, kind of a cool little tool there for you to use. Measuring, I'll show you on the next project, and let's just switch over to that now. So projects, okay, roundabout. So this project's very early in construction. We actually only have 2 drone flights at this point, but we're going to continue on here for another season. So we'll have a lot more flights as this project progresses. First flight. So this was right before we were setting a con span, and then right after we set the con span over a creek. Again, you can kind of see how this is all overlaid. Again, the map on the left side, and we have specific locations through here that are actual surveyed hard spots that don't move, and that's going to help us with the measuring that we didn't have on the Kenwar project. Just flying in some photos here. Again, you can see the high quality, and you can see materials on site, equipment on site. See the arches over there on the far side. Let me see if I can get the mesh. Might not work here because of the stone. Let me try going to the second flight maybe. Yeah, I don't think it likes the mesh here. Get the point cloud, try one more time. Yeah, okay, mesh doesn't want to work. So let's just go back to the point cloud. I'll show you, there's a stockpile there. I'll measure around the area of that stockpile. So click the measuring tool. Here's all your measuring tools. You can see various items that you can use. One of the nice ones is going to be that cut and fill volume. When we get more survey data as the project goes on, we'll be able to even see the volume of this pile. So here you can click multiple points. It's going to grab all those points around here and give us a square foot of it. So there you go, nice quick little feature there to get that measurement. Let me go up and exit here. So there you go, there's your total square footage for that little stockpile there. And that stays kind of on the screen, so it's nice. You can pan around and it won't move away for you there. I'll try and take a measurement over here. That should be good. Let's go ahead and measure the width of the road. We had a single lane alternating traffic. So this is a narrow section of roadway here, just over 11 foot. So yeah, you can see just almost just over 11 foot there. I might be off the barrier a little bit, but again, nice little measuring tool. Just for information, if you want to grab a quick measurement, you can do so on a project. Okay, you also get your markup tools here. So just like on the other project, we can mark things up if we need to. So that's nice. What else? Timeline. Okay, here down at the bottom, this blue indicator. That's going to be our schedule. So we're starting to load a lot of that in now to use that to progress the project through construction. Now, I don't have a 3D model to implement, but let me BIM here. But because it's a roundabout, we figure we can do quadrants and display it that way. So this is kind of the general start of what we're going to do for a model, showing that we're going to work on each quadrant at a time and work our way around. So as I lay this over the plan, there it gives you an indication that we're on schedule. So the green shows we're on schedule. And obviously, if we weren't, that would be shaded red, showing that we're behind and where we should be moving forward. So again, nice way to show you how your project is progressing. Again, turn on the cameras here. So again, those pyramids, we've got a bunch of high-res photos. Let's see if I can check that measurement again. So even in the high-res, you can zoom in and take measurements there as well. So let's see, try and get white line to white line here. Yeah, so looking, again, we had 11-foot lane, so you have probably 10 foot between white lines there. So again, cool tools to use. And again, I think once we get some of that, some more flights in, we'll be able to get better survey data for measuring volumes of cut and fill and stockpiles. So look forward to that. Just finally to wrap around here you can kind of see those pyramids. That's the flight of the drone as it worked its way around on that given day. And you can see the elevation changes and the location changes as it goes around. Click any one of those photos for use. Sorry if some of those are kind of small to see doing that, but again, I think we're going to have some great potential coming out of this in the very near future once we go planless. I want to thank you again for attending my presentation here today. I hope you found it beneficial and informative. As we go into Planless 2025, I think these tools are going to be essential to how we work in construction and going to be essential for how we do what we do. So with that, my contact information is on the screen here. Feel free to reach out to me if you would like to discuss any of these items further. Thank you.
Welcome everyone. My name is Stephen Moore. I'm the Chief of the Photogrammetry and Survey section down at the Construction Materials Division in Harrisburg. Today I'll be presenting on Lidar Solutions for mapping, monitoring, and asset management. Our section has been involved with Lidar since 1999. We were one of the first DOTs to purchase a terrestrial Lidar scanner, and we've been following the technology ever since. Today we're going to look at two case studies that we've had. One is FHWA funded evaluation of SLAM technology. And the other is utilizing our Trimble X7 scanner for MSE wall monitoring. In 2021, we received FHWA funding to do an evaluation of SLAM LiDAR technology. So SLAM is simultaneous location and mapping, which differentiates this. It actually has an IMU on board that allows the system to be utilized while either walking or vehicle mounted. It has a 100-meter range, originally designed for indoor applications. Of course, we're using it for some outdoor applications. Again, it can be handheld, vehicle mounted. You can even mount it to a UAS. It collects 300,000 points per second and has a relative accuracy of about 6 millimeters. So these 3D point cloud collection are actually utilized to produce 3D models. In the top video, you'll see this is that GeoSLAM unit mounted at the top of that Dodge pickup truck, and we're moving at slow speeds down along SR 897 in Lancaster County. You can see that unit turning and collecting the 300,000 points per second. And as it comes down to a stop there, that white building you see off in the distance is actually the blue outline of the building you see in the image below. And you can see all the road detail we're able to collect. You can see that yellow striping in there. You can see the red for the poles and the yellow of those wires. The reason we're looking at this, we now collect a lot of LiDAR on the roadways, but we use it with really high-grade mobile LiDAR systems through our consultants. Those units can cost up to $1 million to purchase, and they're very expensive for us per mile for data collects. We could also do it through terrestrial LiDAR. It's going to be even more accurate, but it's very time consuming to move those terrestrial LiDAR stations along that roadway, collecting the data you need. And of course, another thing that we're looking at is utilizing conventional survey, but keeping those surveyors out of that roadway, right? Keeping them off that double striped yellow line, off those road edges, and really try to utilize the technology to keep our surveyors safe and get their services for the off-road data where LiDAR really struggles in vegetated areas. In our SLAM for mapping application, we have workflows and processing. So in the upper right, you can see the GeoSLAM Hub software. It'll actually show the path that the vehicle took. It shows it as little footsteps as though you're walking it. But that's the path we drove around Weaverland Church, that same SR 897 project. We take the results from that GeoSLAM Hub, we move that over to Trimble Business Center, and there you can see in that center image a color-coded intensity where Trimble will actually show us that building in 3D. You can see the details on the windows in the front of that church. And then to the bottom right, and we export out from Trimble some surfaces, some point cloud data. We're able to import that into our Bentley Open Roads Designer programs and actually do whatever we want on those roadway surfaces, create planometrics, tweak those surfaces, utilize those point clouds as context, and hopefully deliver to our design team exactly what they need. As part of our SLAM evaluation, we also wanted to look at 3D point cloud collection for digital as-builts. So in the image you see to the upper left, that's a roundabout that they built for a new welcome center in District 5. We were able to utilize that Zeb Horizon scanner by hand, walk around that roundabout, pick up the details. I mean, you can see the paint stripe, you can see the center, and of course, we'll be able to rotate around in 3D and see all the details in there. We also were able to collect on a steel girder bridge. You can see we've been requested through photogrammetry to do many captures of historic bridges specifically with our terrestrial scanners. And it's very time intensive to move those scanners from position to position to try to get all the details specifically in those steel girders. So with this hand scanner, we're able to take that through and basically paint what you see. You're able to move it around and paint and get that superb detail that you see in there. And then the last case is in this animation. So we drove this roadway up the Pocono Raceway, much like we drove in that second slide with the Dodge pickup. And you go through, and you can see we have this classified. So classifying means that we can have the software filter out for us, like what is that green vegetation? What are those red poles and signs? The blue you had seen through there are different buildings and even some fences and structures. And we're able to go, and again, you could easily pick out pole and sign inventories from here, identify the location of utility wires, and we're hoping to, and extracting that ground surface. So as this animation continues to roll through, you'll see a little icon of a surveyor standing in the middle of the road. And again, that's one of the things we're going to do is, utilize this for safety. I think it's really easy to see how driving these through the roadway is a much safer alternative to having personnel standing in the middle of the road. And the third aspect we want to look at is 3D point cloud collection for asset management. So we're able to take that scanner down to Fort Hunter State Park in Harrisburg, and you can see in the photo in the upper right of a covered bridge down there. And we're able to take that scanner again, handheld, walk through there. You can see the details in the image below. That's actually the point cloud rendering that we're able to produce. A lot of detail. It can get a little bit artistic with these. One of our technicians did, and also in the animation that you see that's running now. Okay, and we're able to walk through there one time, one complete scan. If we were to try to collect this with our terrestrial scanners, it would take many setups to show the details of those beams and to get everything collected. The SLAM technology really offers us a great opportunity to move through here once and done and get the scan that we need. Another asset that we looked at was a culvert in District 8. So as this animation kicks off, you see we were able to scan on top of the ground, show all the context that's needed to be there, utilize that to geolocate, georeference this scan in space. As they tilt up, you can see the culvert run under the road. And with our software, we're able to cut away then all that roadway surface. And you can see in the image to the left how you're able to cut away that culvert to see the detail. You can see those pipes. You can look in there and see deterioration. A lot of detail comes out of that. On the unit 2, there's also a video scan that occurs while you're collecting the scans. So we saw some really great advantages to this scanner right off the bat. It's lightweight, easy to use. We can mount it to a vehicle. We can transfer it between survey crews or even different departments depending on the applications. We can access hard to reach environments, or as you see here, this is a railroad crossing that's moving now. The detail you can get on something like that. This is that welcome center up in District 5 that I had mentioned. We actually walked the outside of this and a bit in through an outdoor eating area. And you can just see the details that the SLAM is able to pick up. The last animation is of a pedestrian walkway. We scanned that by hand. And again, you can take these scans, you can geo-reference them, you can pull them into your projects and be able to have a really good detailed digital as-built of what's there. So as part of the evaluation, of course, there's some limitations that we ran into. The unit must be utilized, whether handheld or vehicle mounted. It must be done in a closed loop scan. And those scans must be limited to about a 20-minute duration. And we were putting the scans together. We saw some of the point clouds getting some divergence or drift. So in the image to the upper left, you can see how the bottom scan is actually what we want to see. And as part of that drive, we started to get some drift in that upper scan pulling away and lifting away and moving off to the left. It really requires vertical feature-rich environment. So poles, signs, buildings, and even that tree canopy actually is a good feature. We didn't realize that first. I thought that would be a little noisy and poor, but actually those trees help out a lot. The other thing is noise. So in the image to the bottom left, you can see between 3.5 and 3.6, so about 1/10 of a foot, we're seeing noise on there. So this was a really data-rich scan of a curb line. I was able to cut a perpendicular cross-section through there and really look at the kind of true noise range that we saw. Again, 1/10 of a foot as you go up, and you don't quite get that hard 90-degree top of the curb. And again, about the 1/10 of a foot noise on the top of the curb. But again, for our applications that we're looking at, we think this is probably going to be perfectly fine. We can look at some of our processing. I know we talked to the manufacturer just the other day, and tweaking some of our processing procedures, I think, is going to help fix a lot of this. So we're submitting our findings for the FHWA SLAM evaluation now, but we also want to do some explorations of some other types of LiDAR and do some true comparisons to these. One of those being the Carta Stencil Pro. We've had them out for a demo. Topcon was able to bring out their RDM1 unit. It's a downward facing LiDAR scanner. And we're hoping to set up a demo with the Trimble MX50. So, what is driving all this? And the things that's driving it is this new 3D digital delivery directive for 2025. And we're being tasked on the survey unit to provide much more data-rich, dense data sets, so that when you're doing your 3D modeling and your 3D design, that you have that good dense terrain built from your survey. The other thing is personnel safety. We want to keep everybody safe out there, and if we can do it through mounting these onto vehicles, collecting those roadway services, we can utilize our survey personnel on the off-road data collects, getting those drainage structures, showing the ditch lines and the swales, and other things that LiDAR just does not do a good job with, especially in vegetated areas. So we want to best use our personnel and be able to deliver the products that we need moving into the future. The second part of this presentation, we're going to look at the Trimble X7. We were able to purchase a Trimble X7 through the Productivity Improvement Fund through PennDOT. It's a full 3D scanning system. This one has an 80-meter range with a very low noise level. So this scanner is getting back direct returns. You're not seeing that 1/10 of a foot noise range. You're going to get 2.5 millimeters at a 30-meter range. If the scanner's 30 meters from that wall, you're only going to see divergence of about 2.5 millimeters. It collects at 500,000 points per second, has a relative accuracy very tight of 2 millimeters. It has some mobile software called Trimble Perspective we're able to use in the field, and we're able to do our data analysis through the existing Trimble software that we have in-house. So just looking at the 3D point cloud and reduction with the Trimble X7, I actually borrowed this video from the Trimble website. It'll show you the X7 and also some of the results and some of the field applications. But our main reason for acquiring this, it's a self-leveling and auto-calibrating. So we can take that unit, go and set it up, press a button, it auto-levels and starts scanning. It can pick up your full 360-degree view scan with photos in about 4 minutes. It's lightweight and compact, easy to move, easy to utilize. In the mobile field office, like I said, on a tablet, we'll have that perspective software. We can auto-register those clouds in the field. We can colorize those point clouds in the field. And the files that we have at the end of the day are ready for our analysis. We dump those into our other Trimble software products, and we're able to go and start analyzing those MSE walls. It's a great time savings for us. Great, again, on safety, keeping those folks into safer positions, being able to carry that lightweight scanner, much better than the old scanners we have typically been using on those products, on those collections. So here's our case study. Again, it's a MSE wall that we're tasked with collecting. You can see the image of it above, and then what that LiDAR scan looks like. And with this X7, I mean, you're really getting every detail that you need of that wall. So typically workflows for this, we establish some horizontal and vertical control on those sites. We do preliminary base scans. And then in accordance with Pub 238 and our own Pub 122M, we do these in-depth inspections about every 10 or 15 years, depending on the wall. We then document and report any separation, you can see if those panels are moving in any way. You can see if the wall's moving. We can do that through heat maps, cut and fill maps. And we're also exploring some other simpler, like Excel report deliverables that we can give directly to the bridge unit and those that are actually analyzing these. We can also use this X7 for mapping purposes. We do a lot of mapping down in our materials lab down here, and this is another unit we were able to take through. And you can see in the image below what the materials lab looks like, and all the little numbers you see are actually scan stations that they took to collect data in and around there. In the upper left image is that LiDAR image. In the bottom, you can actually see the front of our building, and that's actually where we took that cutaway of that sign that was in that image. We didn't specifically get the sign, it was just part of the scans that we were doing out there. This went very fast. At those 4 minutes per scan, they were able to go the whole way around the building and all the access roads where you see those numbers indicated, collect upwards of 50 scans in less than 1 day. Again, they're auto-registered, they're colorized. They want to move those into our other Trimble products. We can pull out the surfaces for those roadways. We can see the details in the buildings and any assets that are around it. We very quickly realized benefits as soon as we got the Trimble X7. It's 50% lighter, more compact than the previous units we've been using. So we can really get that in and where we need it, keep the surveyors out of harm's way. It collects a large range of data, so we can be up close to that wall or pull back from that wall, however we need to get that. It's auto leveling, fast data capture, reducing our field time dramatically on these MSE walls. The field software that we have on there, again, auto-registering those scans saves a lot of time back at the office. We know what we have right there in the field if there's anything extra we need to pick up. It's a once and done solution. The office post-processing, again, the amount that's done in the field, we then bring those LAS point cloud files into our existing PennDOT software to start that analysis, comparing those original scans that we got 10 years ago to the scans that we're getting today to detect any movement that may be occurring out there. I just want to thank you for your time. Again, my name is Stephen Moore. I'm at the Photogrammetry and Surveys section. If you have any questions, you can contact me directly, or if you have any applications you'd like to explore with either of these units, feel free to contact us and set up a project and see what we can do for you. Thanks a lot.
Hello, everybody. My name is Steve Snedden. I'm with PennDOT Engineering District 11. I'm going to be giving you a brief presentation on augmented reality in PennDOT. Specifically, we've acquired for a pilot an augmented reality headset using a HoloLens from a company called Imagion. Okay, so what is augmented reality? I didn't hear a lot about it until recently. I've heard a lot about virtual reality, never really heard about augmented reality until recently. So I'll try to elaborate a little bit. The term augment, the verb, means to make something greater by adding to it. And that's essentially what augmented reality is trying to do for us in many different forms. You can see these pictures here I have on the slide on the top right. You can see that's obviously somebody in the military using an augmented reality headset. On the lower right, you can see somebody that appears to be in the building trades. This depicts some augmented reality where you can see tools and 3D models of things that are not there yet in reality, but he can see them there through his augmented reality headset. So that's essentially what this technology is aiming to do for us. It's to make us more efficient, to make things, to utilize technology in a better way, to make us able to better do our jobs more efficiently. I will touch on that a little bit more as we progress. Okay, so moving along, the specific product that we're piloting is from a company called Imagion. There's their logo there. As you can see, it says connect, collaborate, and capture. And you can see the image below that, has, one central location connecting with different people all over throughout the country. And that's kind of how this product is intended to work in its most simplest form. I don't want to minimize it, but we refer to it kind of as FaceTime on steroids, where you can be having real-time live video chat with people anywhere in the world, while also utilizing some of these augmented reality features that can help solve problems. Specifically, some of the things I see this really helping is facilitating multiple busy schedules. It's a lot easier to get 4 people together for a half an hour when you don't have to travel. Reducing travel time and expenses, pretty self-explanatory. Expedited problem solving, again, being able to get people together short notice without having to travel, viewing issues real time. It can solve things faster. Real-time photo, video, Lidar, and progress documentation. I don't necessarily have that as part of this presentation because I haven't been able to use it long enough to develop any of this footage. But really, when you're wearing this augmented reality headset, the whole time you're wearing it, you can be recording, you can be taking photographs, you can be taking video, and you can be doing Lidar scans of your project in real time, all of which is saved to a central secure location. And additionally, we have our iPads and our iPhones and MC docs and our plans are in all sorts of different locations. You can use this augmented reality headset to have all of your project files in one location, literally at the click of a virtual button. So the case study aspect, I sort of use the term case study interchangeably with pilot program, which is what we're doing. We're just not there yet. That's why I have this handy little graphic. The future is still loading. As I mentioned before, we just got the hardware in our possession, a month ago. We just got it working several days ago. I'm not ready to give a detailed analysis on any sort of a case study or pilot program. What I can tell you is that we have this for 4 or 5 months. We'll be using it in construction, where we're going to have our inspectors and our IICs and our TCIs using it, just doing their day-to-day jobs. We're going to have our materials unit test it, where they can do some remote testing. Maybe they don't have to be at a plant. They can, use the AR headset while sitting at their desk and participate in some things. Design's going to use it. For example, scoping field views, we think it could be useful. Bridge inspection can use it. That would be pretty self-explanatory there. Maintenance, they're going to get a shot with it. I really don't know how they're going to use it, but they'll get a chance. So within a few months, I should have a much better idea of what this is good for and what it is not good for, and I will be providing a much more detailed presentation at the upcoming project development workshop. Okay, so what works and what doesn't? I've mentioned several times I don't want to sound like a broken record. There's a lot of this we just don't know yet because we haven't had enough time to experiment with it. What I can tell you so far from the time that I have had with it and the experiences that we have used it on, we have a few issues, and I also see a promising future in a few areas. So some of the issues we've encountered so far is just a general unfamiliarity with the hardware toolbar and the online interface. It's just a little bit unnatural to look around you and click on things that are moving with buttons that really aren't there. It takes some getting used to. The online interface also not very user-friendly to somebody who's not familiar with it. So these are some things that I'm sure they're going to be working on for many years to come, and they're going to get better. We had some IT problems. Specifically, this hardware will not work with anybody on our VPN network, or to be more specific, the online app is not allowed to travel through our VPN. So far, people use on the PennDOT network via VPN or in the district office, they can't participate in these conferences. You have to be on your home Wi-Fi or using a hotspot, something that is not the VPN. We're working on that as I speak. And some of the tools are limited. I think the main tools that I can think of that we can use is we can measure, we can take photos, we can take videos, we can take 3D scans, but even the measuring and the scans are limited, that you can only measure so long. You have to be within a certain distance to do it. So the tools are still fairly rudimentary for our industry. However, I do see a promising future here. Once we improve on some of these issues, I can see this being a really big time saver, which translates into a money saver. More advanced capabilities, when we can do better measuring, when we can do better scanning, we can do better photographs, it could work a lot better, save us more time, save us more money. And another thing I see here is that there's many sectors currently working on augmented reality. We're transportation, we're PennDOT, we're just one sector. Vertical construction is working on it, as I showed you in a previous slide. And the military is also working on it. There is a lot of investment getting pumped into this technology, and the more people that are investing in it, the more people that are using it, the more people that are developing it, I really see this improving quite rapidly. I wanted to touch on the cost-benefit aspect of this, and Imagion's website has this calculator. I'm in no way trying to plug or promote their product specifically, but this is a nice way to visualize, potentially how much money, could be saved utilizing this product or a similar product. So, for example, this example I'm using right here, let's say I have 2 hours driving. I have the cost per person hour, including overhead of $50 an hour, 60 miles driven, no flights, no rental cars, no nights in a hotel. And so you can see that for 1 2-hour trip with one person, you would save $112. So, 2 people would save $224 and so on and so on. So I believe the monthly cost for this product somewhere around $3,000. So you can see how if you had multiple meetings with multiple people, it would very quickly pay for itself. Okay, got to make this quick because this thing starts playing on its own. This was our very first run with the IIC out there in the field, wearing the headset. And while connected live to the participants that you can see on the right, you can see the toolbar on the lower left part of his screen. You can see a plan set to the right of his screen. And this is all live, real time, while he is on site. And I'll just sort of let this play through.
30-25 station, looking station ahead towards the roundabout. North is to my left currently as I'm standing here. Just to give you alignment. So you want to shift to the next page?
I'll add one thing here. The audio is a little rough because he was shielding his eyes from the sun, not realizing that he was inadvertently blocking the microphone. So we learned from that.
So here again is our baseline, 3124 on my pointer. I'm about at 3125 on my pointer. And our targets up through here of discussion. You see the side road on the right of this plant set here. We're actually going downwards. That's actually a post office entrance. Pretty active. It's actually the most active post office in the country, probably. So many people come in and out of there. But that's kind of where I'm standing, right at 3125. That's right there.
So anyway, you can see what this looks like. You have the participants on the right live with the gentleman in the field with the plan set actually on site, sharing live information amongst ourselves. I'll try to get into a little bit more of the detail in the next slide.
Again, is it roughly 15?
Okay, so here we are. We took the HoloLens, the AR HoloLens down by the bridge, and we're going to show you a little bit more of the functionality here.
Feet.
Yeah, it's a 15-foot radius, so about 7.5 to 8 feet in front of you, and then it'll remember that map around it up to about 100 square feet or so. So that's what we are pushing up bigger. We're making that map it builds over time larger, but it scans in front of you in about 7.5 feet, and it'll remember that, up to about 100 square feet.
So it's not. So as he walks around the site, it's not storing the entire project in a 3D Lidar model anywhere.
Yeah, not yet. So you can think about it as it's grabbing a snapshot of the job around him in 3D. So when we hit the upload on this, we'll see how much of the bridge it caught.
Okay. So now for him.
What you just saw was Mike was trying to snap some photos, but he wasn't quite, or drop some pins, but he wasn't quite close enough for it to work. So that's one of the shortcomings as of now.
To snap a LiDAR image right now, what's he have to do? Look at the bridge and click on the grid?
Doesn't even have to look at it. So everywhere that those pins are, that's all going to get captured. Dropping a pin tells the headset, hey, keep track of where I just placed this. Because it's going to keep the markup accurate even on places where it doesn't have that in its immediate memory.
So this is convenient. It drops the file right in the chat box. So I can just click on that, right?
Yep. Although I think that might try to launch you out of the call.
Yeah, it tries to take you out. Yeah.
I have to save as.
That's a good note, though. We should make that download instead. And if you take a look at the folder, I'm going to turn your attention. Take a look at the file sizes. The first one Mike took was only 280 kilobytes. The one we just took is over twice as big, and it's got that whole front area of the bridge where he just put the push pins and all the dirt behind him where he was walking around. So if you were to walk down that bridge, drop some pins on the underhang there, get a good look at that, it's going to include that underside as well as all that terrain.
The other thing, too, to mention, you don't really have to do the 3D scan until the end because it's building a mesh the whole time, and it will end up whenever you click on the grid, it's going to do the scan for everything that it's seen.
Well, that pretty much wraps up what we have so far. As I mentioned, we just got started with this technology. We just got it working literally days ago. We still don't have it fully functional. We're still not very familiar with the interface, the toolbar, just about everything. But I tried to give you a little bit of an example of what it could be used for, and I agree it was a little rough. I hope you forgive me, but didn't have a lot of time to pull this together. So with that being said, that's all I have for this today. As we experiment with this for the next several months, I should have a much more comprehensive presentation and to provide at the PDW. So with that, I'll leave it open to any questions. Thank you.
Hello, my name is Nicholas Schroeder. I work in the Bureau of Project Delivery, Bridge Design and Technology Division, Structural Materials section, where we oversee operations for fabricated structural steel and precast members. Today I'll be discussing some pilot projects we have ongoing as part of the I-95 corridor, those technologies being virtual inspection and phased array ultrasonic testing. These technologies were programmed for use via special provision for steel fabrication on I-95 Betsy Ross Ram's ECMS 79904 structure number 37600, which is being fabricated by High Steel Structures located in Lancaster, Pennsylvania. The structure consists of 30 built-up plate girders, cross frames, application and coatings, and other miscellaneous components. The special provision for virtual inspection was written in such a manner that allowed the fabricator freedom to select a system meeting certain minimum parameters such as image quality and communications. In this case, the fabricator selected a system which uses a real-wear headset that can either be mounted to a hard hat for construction and fabrication work via OSHA-compliant connections or banded to your head, which would be more practical for a laboratory setting. The headset includes an integrated camera, flashlight, heads-up display screen, and microphone for communications. The headset tethers to a dedicated phone acting as a hub for connecting to a Wi-Fi or cellular network. Once connected to a network, live stream communications can occur. Live stream communications are conducted through a web-based conferencing collaboration platform. This platform can accommodate as many individuals as required by sharing an access link. Once admitted to the conference collaboration platform, individuals will be able to directly communicate with an inspector. The inspector has the capabilities to capture photos and record video. As a remote user of the system connecting through the web-based platform, you have the ability to communicate with the inspector, capture photos, and share and annotate documents. The photo seen here was captured, annotated, and shared with the inspector all within this platform. The shared photos or documents are projected in the heads-up display located on the articulating arm of the headset. This feature helps communicate with the inspector if a specific area is of concern. When capturing photos as the inspector or a remote user, the system is programmed to optimize the image regardless of available bandwidth, and in some cases will sacrifice the live stream communication to enhance the photo capture. The virtual inspection system is being evaluated for all aspects of fabrication and to identify potential problem areas for remote users. Areas such as measuring tight fit-ups and using other gauges or digital displays with high potential for glare would be some examples. To date, the system has performed well in these areas with the exception of troubleshooting some connectivity issues. The system allows for increased productivity by allowing project managers to quickly gain an understanding of issues via means of seeing what an inspector sees in real time. This eliminates to some degree the timely back and forth photos, phone calls, and emails required to typically gain a good understanding of an issue. As an example, the department recently experienced an issue regarding how to measure deformation of tubular members after cold bending. The remote visual inspection headset and conferencing system was used in this case to resolve the issue by including key personnel from the district, fabricator, central office, and design engineer for an understanding of where and how measurements would be recorded. This occurred after multiple conference calls trying to verbally explain the measuring process. This is one example of time savings to the department and project staff. Additionally, allowing new hires to attend these virtual inspection conferences aids in their training process as well. The previous slide mentioned time savings in terms of efficiency for problem solving. As an inherent bonus, this also eliminates wasteful travel and other associated costs. Fabrication shops are spread throughout the entire country, with the furthest active shop in Omaha, Nebraska. Having a system like this in place at all facilities would allow the project manager/engineer to virtually visit multiple shops in a day's time to observe issues and check up on the status of various projects. Or the system could be used for routine quality assurance audits. From a safety perspective, the system limits the number of personnel required to be in the work zone to observe activities. Subsequently, this reduces the potential for hazards. It's also important to note the system was in place prior to COVID, so adaptation to COVID-19 restrictions, while still maintaining a level of communication and oversight with our inspectors, was very easily achieved. Throughout the trial period, and like with all good pilot projects, numerous lessons were learned about the use of the systems and its operations. Since the system works on a web-based platform, maintaining a stable internet connection has been the biggest challenge. In order to combat this issue, Wi-Fi boosters were placed throughout the fabrication facility. The developer of the web-based platform provides frequent updates that often cause issues when attempting to join a live stream for the user. As previously stated, the system is tethered to a cellular phone, and the cord connecting the phone to the RealWear headset has been known to loosen and drop the user from the live stream. It is recommended that targeted inspection activities be a focus of using the system, as the battery life of the phone is roughly 1 hour, 1.5 hours. The system does allow for inviting external guests by email notification with a link to join. However, we have experienced issues where the emails were filtered to the spam box or had a latency to arrive. The two biggest questions before using a virtual inspection system were related to image and sound quality. From a live streaming perspective, the image quality is highly dependent on the network connection, but also on the inspector's movement. This requires the inspector to move a little slower while maintaining a still head. Capturing photos is also dependent on dynamic movement, which causes blurriness of the image, as would occur with normal photo capturing. It was discovered that videos cannot be recorded while live streaming is occurring, but the image quality has been excellent in the videos we have recorded. Much like a construction site, fabrication shops are noisy, if not noisier than a construction site due to the sound being contained. This was a concern of how well the communication features would work during operations. The noise filtering features of the headset are quite impressive, to the point that very little excess noise other than the inspector's voice is broadcasted. As part of the department's commitment to advancing the use of technology, we are looking to procure a RealWear headset of our own for using in a more broad environment. Testing the system at precast facilities and facilities that are a little more isolated, and also field sites, are the primary focus points for further evaluating the use of this system. Switching gears slightly, but staying with the theme of digital delivery, the department has been piloting the use of an advanced non-destructive testing method in phased array ultrasonic testing. The method utilizes the same principles and theory as traditional ultrasonic testing, but allows more functionality and interaction with the data by virtue of testing with more than one piezoelectric element. The key benefits of using this method over the traditional is advanced visual aids, reduced inspection times, and the ability to maintain a permanent record. This technology was also programmed for use via special provision for non-destructive testing of critical welds, such as a welded web and flange splice, which traditionally are tested using radiographic testing methods. A key objective to this pilot is to help aid in the determination of using phased array ultrasonic testing in lieu of the radiographic testing method. When compared to the traditional ultrasonic testing method, which outputs an analog response at a fixed test angle as shown in the top right, phased array ultrasonic testing takes advantage of using additional piezoelectric elements to integrate the data and create images for multiple scanning views, such as section views and plan views. Instead of being restricted to a fixed testing angle, the method allows for sweeping through a range of test angles. But ultimately, the key advantage is the advanced visual aids, which help to improve the understanding of signal responses and interpretation of data. When used in lieu of radiographic testing, there is the potential for reduced inspection times as the system is faster to set up and does not require isolating an area of the shop due to radiation hazards. Radiographic testing is highly dependent on radiation penetrating a member to reach a data collector. In the case of thick members, this can take quite a bit of time, and the ultrasonic testing process is much faster. Radiographic testing equipment is typically 50 to 70 pounds in weight, whereas the ultrasonic equipment is much lighter. The phased array ultrasonic testing process using encoded line scans as seen here in this video allows for collection, storing, and archiving of data for interpretation at a later time. The encoded aspect in the data collection is in terms of distance or location where the data was collected on the weldment. The current radiographic testing process maintains a permanent record in the form of a radiographic image, or it might be easier to visualize as an X-ray. Since the phased array process is heavily dependent on having additional advanced visual aids, this process maintains that status quo with the encoded line scans as they are archived as a permanent record. The special provision for this technology was written to include assessing another component of the phased array testing process of artificial intelligence, or automated detection technology. This technology is already a market available software, so there is no need for program development. The software requires that the data be in an encoded format and is post-processed. During the post-processing application, the software evaluates the data for any quality issues during collection that may render the data unusable, and then evaluates the data for potential defects. If defects are located, the software will automatically flag them and perform sizing applications to report length and location. By using this software, the time for a technician to analyze data is cut tremendously. As an example, it may take a technician 5 or 10 minutes to analyze data from one welded joint, where the automated detection software could complete the same task in under a minute. In large volume shops, this could translate to a huge cost savings. The use of this software also helps cut down the ambiguity of human error in the interpretation process. The automated detection software has two main software outputs. One being a graphic output on the left, which shows a section and plan view of the weldment with flagged areas of potential defect locations highlighted for further evaluation. The second output is a detailed spreadsheet with all the information and parameters for testing, data quality, defect location, and more. These features used in combination with the original data greatly aids in the overall documentation process. As a result of this pilot project, a few indications have been flagged requiring additional evaluations, but determined to be caused by external influences such as ponding of the couplant material on the surface of the part, which is required to transfer the ultrasonic wave from the transducer to the test specimen. As a summary, both technologies are still being tested for use, with the virtual inspection technology being used about 3 times per week for an hour a day. Some connectivity issues still occur, but for the most part, we have found solutions to many of those problems. The phased array ultrasonic testing pilot has been performed on half of structure 37600, with the other half to be completed in January of 2022. The schedule has been significantly impacted by COVID, but we look forward to the completion of this project in 2022 to further evaluate the use of these technologies on future projects. Thank you for your time. If you have any additional questions regarding these technologies, please feel free to contact me using the information displayed here.